In the last video, we talked about cin and getLine, which allows us to get input from the user. Today, I want to clarify the concept of objects and show you predefined functionalities you can use in your program. In the last video, we had something like this. We were trying to get user input by using cin and using getLine. Of course, make sure to check out the latest lesson about getting input from the user using cin and getLine if you missed it. Now, in the last video, I spoke about object and dot notation. This is the dot notation right here, and I spoke about it very quickly. But in today's video, I want to take my time and explain what this concept is. So when I go ahead and write cin dot, as you can see, there's a lot of functionalities and properties that appear. Now, how does this works, or why do they appear? Now let me explain this. So if you hover over cin, you can see something called istream right here. Cin actually is an object of a type called istream, or a class called istream. So this is an object of type istream. And what is istream? It is a class that provides input functionalities. Istream means input stream. So this class provides input functionalities that the objects of this class can use. So the object cin is able to use the functionalities of the class called istream because it is an object of this class. A simple explanation about this is that think of the object cin as a follower of the class called istream. Now this is a very simple explanation. Of course, further in this course, when we go to the advanced level to classes and objects, you will understand it even more. But for now, think of the object cin, or any object, as a follower of their class. So cin is a follower of the class called istream. Let me hover over it. Okay, so cin right here is a follower of the class called istream. And because it is a follower of this class, it can access the perks of this class, like, for example, functionalities and properties. So, how to access those perks and functionalities? Okay, so if I go ahead and say cin dot, using the dot notation, I am able, or the object is able, to access the functionalities and properties of the class that they follow. As you can see right here, cin is able to access the functionalities and properties of the class called istream. Now what about cout? Well, cout is an object of the class called ostream, output stream, that provides output functionalities. So if I go ahead and hover on cout, as you can see right here, it is an object of type istream. So it is an object that follows the class called istream. So because it is a class, or a object that follows the class called istream, or ostream, then it can access, using the dot notation, the functionalities of this class. So if I say cout dot, as you can see, again, it can access the functionalities of the class called ostream. And so this is a simple explanation about the objects and the dot notation, and how the objects can access the functionalities of their classes using the dot notation. Now I can do the same thing for the string variable right here. So if I go ahead and say full name dot, as you can see, there is multiple functionalities and properties that we can access using the string variable. Now why is that possible? So what we did here is created an object called full name of type string. Now string is a class. Just like the ostream and istream classes, it is also a class. And a class like string or any classes provides functionalities and properties that their objects can use. So think of full name right now is the follower of the class called string. And because it is a follower of this class, then we could use the dot notation to be able to access the functionalities that this class can offer for their followers. So if I go ahead and say full name dot, as you can see, we get multiple functionalities and properties that we can use using our object. Okay, now do this method of dot notation works with data types like integers or double? Well, let's see. I have a integer variable right here called age, and let's see if it works with this variable. So if I say age dot, as you can see, nothing appears. Weird. Why does nothing appear right now? Let's go ahead and declare a double variable called double1. Let's say double1 dot. Also, nothing appears. So let me tell you something. Data types like int, short, long, also we have double and float, char, bool, okay? All of those data types, they are not classes, okay? They are not classes like the string data type over here. They are called primitive data types. And what means primitive data types? Well, it simply are data types that don't have classes or objects. That means you cannot use the dot notation to be able to access the functionalities of these data types, because first of all, they're not classes and they don't have simply any functionalities to offer. They are primitive data types. They are the basic data types you can have in any programming language or on your computer. So this is why you cannot use the dot notation using any of these types. Now we saw that we can use the dot notation with the string to be able to access the functionalities that the string class can offer, right? So now what I want to do is show you a couple of functionalities you can use to be able to manipulate your string, okay? So let's go ahead and start with the first one. The first one will be the size method. So let me say something like cout and say a message, so the length of name is the following. Again, let's use the dot notation, so name dot and write size. So the size function right here returns the length of the string. So what is the length of this string? It is 4 because it has 4 characters. So it should return us 4. So let me say something like this. Go ahead, compile, and let me go ahead and wait for it. Okay, let's launch. As you can see, the length of John is 4. So let me go ahead and say cout and ask a question. So I will say is the string name, I'm gonna put it inside parentheses, is empty, for example. I'm asking a question, and I will say name dot empty. Okay, now the empty function returns either true or false. So it will return true if the string John or this name variable contains an empty string like this, or it doesn't contain an empty string. So like this, there's a value called John. So because it returns true or false, it makes sense for me to use the property called bool alpha. And we saw it very much in this tutorial or lessons. Well, basically bool alpha turns true or false to their respective value. So when you cout, for example, true on your console, it will appear as 1 and like this. And when you cout the value false, it will appear as 0. With bool alpha, 1 will appear as true and 0 will appear as false. Okay, so let's go ahead and try this. So compile again, let's launch right now. As you can see, is the string name is empty, false, because there is a value. So if I go ahead, take off the value, we could go ahead, compile again, and launch. As you can see, we get true because the name variable stores a empty string, which means the string is empty. Okay, so let me go ahead, rewrite John right here, and go to the next function. The next function is called append. And so let's go ahead and say cout add ny, let me put it in parentheses, ny to John. Okay, so we should get Johnny. Okay, when you add ny at the end, we should get Johnny. So let's go ahead and display this like this. And now how to use the append function. So I'll say name.append, and what you will mention inside parentheses is the string that you want to append to the string name. Okay, so let's say ny, and this will append or concatenate this string with this string. And what will happen is that we should get the value of Johnny because it will put the ny at the end of the string of John. Okay, so let's go ahead, add endl, and by the way, it is the same thing of saying name plus equal to ny. It is the same thing. You are concatenating two strings together. Okay, and so let's go ahead and launch this. So I'm going to launch it. So compile and launch. As you can see, add ny to John, we will get Johnny. And by the way, if you go ahead and cout name right now, you will definitely get Johnny, not John, because you changed the value of the name variable. Okay, so that put this in mind. As you can see, we get Johnny because you changed the value completely. Okay, so let's go ahead and continue. So the next function will be the at function. But before we go ahead and understand the at function, I want to explain to you the concept of indexing in programming in general. So let's say we have the value of John. Okay, let me just write like this. So John like this. And you will know why I'm doing it with space. So in programming, each character have a certain position, or yes, certain position. So right here, the value of John or the string John, each character of this string has a position, okay, or an index, we call it in programming. And indexing in programming always start with the value of 0. So the first element right here, which is J, is at index 0 or position 0. The next element is at index 1 or position 1. The next element is at index 2 or position 2, as well as the last element is at index 3. Okay? And as you can see, each of these characters has their own position. So 0 for the first element and 1 for the second, and you understand the concept. So basically, this is indexing, and it is very important for you to understand it. Keep in mind that always indexing in programming starts with the value of 0. So the first element is always at position or index 0. So if I say like this, cout, and I'll say accessing the second element of John, so the name, John, excuse me, it became now Johnny because we're appending ny. So let's go ahead and display this second element. So if I say name dot at like this, and inside the at function, you need to mention the index, okay? So the index should be a number, of course. So if I say the value of 2, let's go up there to this variable and see what is at index 2. So we know that J is at index 0, this one is at index 1, the O, and the H is at index 2. So right here, we should get the value of H, right? Let's go ahead and see. So, oh, I forgot to compile first, and now I could launch. As you can see, accessing the second element of Johnny, it is the value of H. Now if I go ahead and say something like 4, let's see which element will appear. Okay, so if I go ahead and compile first of all, then launch, as you can see, the letter N of Johnny appears. So let's count. So 0, 1 for O, H is 2, this one's 3, and so this one is the element at index 4, okay? That's why we got this N right here. Now that we know a bit about indexing, let's go ahead to the next method. Before we do that, let me go ahead and add an L, and now let's go to the next method. So the next method or function is called substr or substring. Well, let me go ahead and show you what it does because I'm having a hard time explaining it. So let me go ahead and say, for example, well, returning a substring from 0, for example, to 4, okay? So let's go ahead and see what will happen. So if I say is name.substr, and first of all, this function takes 2 arguments, okay? And what is an argument? It is an input that you provide for the function. The first argument will be the starting index. So remember, indexing in programming are the position of each character inside a string. So if I go ahead and say, for example, right here 0, this is the starting index, which this means that I want to start from this one, the letter G, okay? So if I go ahead and now say 4, what means 4 here? Exactly, it means that we are excluding 4. Always remember that the end index right here in the substring or the substr function is excluded. So when you say 4 right here, you mean 4 minus 1, which is the index 3. So what it will do, it will start from the index 4 and end at index 3. So what do we have here at index 0? So we have G and 1, 2, 3, and it will end right here. What it will do, it will return for you the characters or a substring that starts from this index to this index. So basically, it will return for us the value of John. Let's go ahead and see it. So compile, and where it is, there it is. Okay, so returning a substring from 0 to 4, it will be John. So as you can see, the string is Johnny, okay? We replaced the name variable that was John with Johnny, okay? But after this, what we did is that we decided that we want to take a substring from this main string. And this substring will start from 0 and will end at 4 minus 1, which is the index 3. And if we count correctly right here, we will get the value of John. That is why we got the value of John right here. And what I want to show you also is that you can store this value inside a variable called a string variable. So if I go ahead and say something like string substring, for example, and put equal right here, as you can see, it works properly because this actually returns a string. The substr returns a string. That is why you can store it inside a value or inside a variable, excuse me. Okay? And same goes for this add function right here. But instead of storing it inside a string, you should store it inside a char variable. So I'll say char index2, for example, and I will say name dot at index2. The at method returns a char. Okay, so at the index2 we have GOH. Okay, we have H, so it should return us H, and H is a character. So next we have the find function. Let's return the index of the character G. Okay, so let's go ahead and say name.find. This find method will first of all find the character that you want to find inside your string. So if I mention the value of G, it will find this string or this character and it will return the index of this character. So if I go ahead and show it to you, so compile first of all, then look at this, the character G is at index 0. Of course, if we offer it a character that does not exist, it will give you a garbage value. So if I'm going to say like this, of course this doesn't exist in our string, so we should get a garbage value like this. Okay, the Cmath header file can offer us functionalities to use on numbers. So if I have an integer, well, let me create first of all a double. So double 1 equal to, for example, 12.123, for example. So if I want to round this variable to the closest and smallest integer, I can use the floor function. So if I say cout floor and use the variable called double 1, and like this, I should get 12 because I am rounding to the closest and smallest integer, which should be 12. Okay, as you can see right here, we got 12. Now, if I use the function called ceil, it will round to the closest and biggest integer. So it will be 13. So let's go ahead and see it. So I will compile and interpret, or excuse me, launch. I will get 13. It is the smallest, excuse me, it is the biggest and nearest integer. So these are the floor and ceil function. They are used to round a certain integer or number, excuse me. But you can use the simple round function to be able to round the double to the closest integer. So right here we should get 12 because we are rounding to the closest integer. However, if I put something like 12.5, for example, it will go ahead and round it to the closest integer, which will be in our case right now 13. Okay, so basic math. Now let's say I will delete my double variable and I will say integer num1 minus 12. Now if I want to transform this into a positive integer, how could I do this? Well, I could say abs num1. Okay, so when I say abs num1, well, basically the absolute value of a number is the positive value of this number. So if the number is actually negative, it will become positive. So there it is, we got 12. But remember, right now it doesn't affect the original value inside num1. Why? Because you didn't assign to it the original value. Excuse me, you didn't assign to it the abs function. So if I say num1 equal to abs num of num1, that means it will first of all pass the num1 variable to the abs function. The abs function will do its job by converting the negative number to a positive, and when it finished doing this, we will assign the return value from this function inside the num1 variable. Like this, we affected the original value of num1, and right now num1 will store a positive value, which is the number 12, as you can see right here. Okay, so the next function you could use, for example, the power function. So the next function you can use by the Cmath header file is the power function or pow function. First argument will be the base. The base, like for example base 2. So if we want to say 2 to the power 4, we should get 16. And so the first argument should be the base. The second argument should be the power. Okay, so if I say 2 to the power 4, as you can see, we get 16. So 2 to the power 4 gives us 16. Next, we have the fmax function. So the fmax receives two integers or two values or numbers, like for example 12 and 13, and it will give you the maximum value between those two variables, numbers. So basically the maximum value will be 13. Now if you say fmin, it will return for you the minimum or the smallest number between those two numbers. So it will be 12, and as you can see, we got 12. Also, we have the square root function or sqrt that finds the square root of a number. So if I give it 16, for example, I should get the value of 4. The square root of 16 is 4, and as you can see, we will get 4. Now, of course, I cannot cover all the functionalities of the math library. If you needed any functionality from the math library, you can always Google it and you will find it, okay? And this is it for this lesson. Make sure to subscribe to stay tuned for the next lesson. Now, if you missed the previous lesson, make sure to check it out, or you can click on one of these videos. Anyway, I'll be seeing you in one of these videos.